Hi, this is Mr. Ward, and this is your video key for Algebra Do Now 29.2, where I'll be introducing quadratics 5 today. So this is actually designed to set you up for that. So what are two factors of 10 that add up to 7? So I'm going to do this. I'm going to make a little x like that, and I need factors of 10. So I'm going to put a 10 here. I'm going to put a little dot here for multiplication. And I need to get a 7. I need to add up to 7. So I need two numbers, one here and one here. They're factors of 10, but they add up to 7. Well, you might have thought of 2 and 5. And there you go. Those would be the ones. 2 and 5 add up to 7, but they multiply to make 10. Okay, and I can go ahead and do this. X plus, this is a thing you can do with this little x. X plus 2, and then x plus 5. So it turns out those are the two linear factors that make this quadratic polynomial. Okay, so what do you do if you get x plus 2 times x plus 5? Wait, that's just what I put up there. What is Mr. Ward up to? It's all part of his evil plan, probably. Giraffes are real. So x plus 2 times x plus 5, we can multiply it out. I mean, don't take my word for it. Let's prove it. So x times x will be x squared. I'm going to multiply the x times the x. Then I'm going to multiply the x times the 5. That'll be 5x. I'll multiply the 2 times the x. That'll be 2x. Then I'll multiply the 2 times the 5. That'll be 10. And it's all addition because there's nothing negative in here. It's all addition. Let's put some pluses in there. And now we can combine 5x and 2x. If you have 5 x's and you have 2 more, you have 7 x's. And that's exactly what we got up there. So that's pretty neat. So this is a way that you can go in the opposite direction of multiplication. You can figure out what the factors are. You can unpack this equation and figure out what the factors were that got it. And we're going to do the same thing with this one. So I'm going to use a different color. Let's use blue for this one. So here we go. There's blue. We're going to have a multiplication dot here and an addition thing here. What I'm looking for are two factors of 21. So 21 is a product of them that give you a sum of 10, that add up to 10. So down here is the sum. So I need two factors of 21 that add up to 10. Well, if you thought of 3 and 7, that would work. Okay, and watch this thing that I can do. I can just put some parentheses around here. I can make that x plus 7. I know that got really sloppy over there. I apologize. And then x plus 3. And these should be the two linear factors of x squared plus 10x plus 21. Now, I'm going to write down 3 and 7 will work. Okay, now here you have x plus 3 times x plus 7, which is the same thing I've got over here. Let's prove it. Let's prove those are the factors of x squared plus 10x plus 21. So I'll start off with x times x, so that's x squared. Then I'm going to have x times 7, that'll be 7x. I'll have 3 times x, that'll be 3x. And I'll have 3 times 7, that'll be 21. It's all positive, so I'll put addition symbols in here. Anything were negative, it would become subtraction. Copy that. Bring it down here. And if I have 7 x's and 3 more x's, I have 10 x's. And that is exactly that. We have the factors right here, x plus 3 times x plus 7, for this expanded form, x squared plus 10x plus 21. Now, let's look at this one. We'll do another one of these little x things. This time I'll use green. That's supposed to be green. I mean, oh my goodness. That wasn't supposed to go like that. There we go. Mr. Ward's bloopers. Okay, there, green. This should be green. Theoretically, the redhead's secret weapon. I was once a redhead, and I wore a lot of green. I still do. strangely enough. So I need two factors of 16. 16 is my product that add up to 8. So 8 will be my sum. There you go. So I need two factors of 16 that add up to 8. And if you thought of 4 and 4, that works. 1 and 16 doesn't work. 2 and 8 certainly don't work. Okay, and I'm just going to make an x plus that, and an x plus 4 over here. And I'll put some parentheses around that, And I actually have the two factors that make x squared plus 8x plus 16. So 4 and 4 will do it. Okay, now let's see what we got here. Oh my goodness, we got x plus 4 times x plus 4. That's what I have over here. That could also be called x plus 4 squared. And so you end up with x plus 4 times x plus 4 equals this thing. So let's prove it. X plus 4 times x plus 4, that'll be x squared when I multiply the x's. And then when I multiply the first x times the second 4, I'll get 4x. When I multiply the first 4 times the second x, I also get 4x. Those are the same dang things. And then if I multiply 4 times 4, I get 16. So we'll add that together. Add that together. Add that together. Copy pasta. And combine like terms. 4x plus 4x is 2 times 4x. I'm just going to make a note here that I've just doubled that. So we can combine it all and make it, of course, 8x. But this point right here is a really important point. I'm going to also make a note that this is 4 squared right there. So this is 4, the x, and the 4 squared are all showing up from all of this. So this is a special case, which is known as a perfect square. This is a perfect square. Why is it a perfect square? Because it's a literal square of x plus 4. And that's why it's called a perfect square. You're going to be using these a lot over the next 5 years of mathematics at the very least. So this is important. We'll spend some more time on this, but I'm going to set this up. This is going to be, I'll give you the basic version of it. So I'm going to have a plus b. I'm going to square that, which is the same as saying a plus b times a plus b. And so I'm going to multiply the a's. I'll get a squared. I'll multiply the b's, which will be b squared. Okay, so anytime you see one of these things and you've got a square in the front and a square in the back, be suspicious about this middle one. Is this middle one somehow related to those squares? And here's how you would look for it. So we're going to have an a times b, so ab, and you'll have another, a b times a, which is the same as ab. So you have two ab's. We can actually put it all together, a plus there, and not just one ab, but two ab's, like that. So I've got an a squared, a 2ab, and a b squared. Well, look up here. I have an x squared. I have a 4 squared from here, right there. And I have a 2 times 4 times x. So here I have an a squared. I have a b squared. So a and b got squared. And then I've got 2 of these ab's, just like I have 2 of these 4x's, which came from 4x and 4x. So I'll give you an example of what you might look for. Let's see if I have x squared, lowercase that, x squared plus 10x plus 25. Well, x squared is the square of x, and 25 is the square of 5. So let's check this out. Let's see if this would all check out for the structure. So is this x plus 5 squared? So x plus 5 squared based on this structure should be x squared, and then plus 5 squared. And then in the middle, I ought to have plus 2 times 5x. Do I have 2 times 5x? Yes, I do. I have a square here, which is 25. I have a square here, which is x squared. And so, yes, this, when you look through here, be suspicious. You might very well have a perfect square. Now, of course, if I had x squared plus 10x plus 25, and instead I had this, show you what I've got. Scroll down a little bit. If I had not that, but I had 26. Well, that's just going to be x plus 1 times x plus 25. That is not a perfect square. So you have to check this middle part and see if it fits the 2 times AB structure. There'll be more on this. Don't worry if you didn't fully get that, but I wanted to let you know about all that because that's coming up. I hope this was